Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math questions out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve today are the ones that you're going to find on page number 243, and today is our lesson number 136. These problems, these exercises, as it says clearly there, these are algebra exercises, and for those of you who are weak in algebra and you would like to improve yourself, your algebraic skill from the very basic, from the very foundation, from the most elementary concepts, on my channels you will find 200 videos on algebra, and this is the schedule. I'm going to quickly go through them as we go through the problem here. Here it says, problem number 1 here on page 243 says, find the algebraic expressions. Find the algebraic expressions. Find the algebraic expressions. Algebraic expressions for these concepts that they're talking about. Now, here's the schedule. Again, if you're interested in improving your algebraic skill, or anybody else that might get some use out of it, in the first 20 days we learn how to evaluate algebraic expression, which is what we're going to do here in a second. Then we learn how to add and subtract algebraic expressions, day number 21 through 50, 30 days there. And then we learn how to multiply and divide algebraic expressions. Finally, I cover the topic of linear equations. And then the last, second half of the semester, day 101 through 200, if you're interested in improving your skill in solving word problems, which a lot of people have problems with, solving algebra word problems, you will find that there are 100 videos, and if you start from scratch from day 101 and go in sequence without missing anything, without skipping any videos, then you will see that by the end of the by the time you arrive at day 200, your skill will be vastly improved in terms of your ability to convert the English language that is put in front of you into the language of algebra. In other words, convert the word problem into an equation, which is the biggest hurdle. Anyway, enough said. The very first problem here, it says, find the algebraic expressions to represent the following, to represent each of the following. First one says, square of y is subtracted from 5. Square of y is subtracted from 5. Is it this? Is it this? Or this? What does this say? What does this part say? This part does not say square of y is subtracted from 5. What this says is that square of y, what this says is that 5 is subtracted from the square of y. 5 is subtracted from the square of y. This is not what we're looking for. This is not what they're asking here. It says square of y is subtracted from 5. From 5 we're going to subtract square of y. And then what? The result is multiplied by 37. The result is multiplied by 37. So that's very simple. This is the result, and you multiply it by 37. That's it. You can leave it like this, or you can expand it. You can open it 37 times 5. Well, I don't know what 37 5 times is, but let's see what we can do here. 7 times 5 is 35, so that's 5. Carry 3. 5 times 3 is 15. 15 plus 3 is 18, so it's 185. 185 minus 37y squared. That's the first one. Let's do the next one. B. I think I'm going to change the marker because this marker I don't think it's very good. It doesn't write very well. Hopefully we'll have better luck with the next one. 3 times x is squared. 3 times x is squared. How do we write that? 3 times x is squared. 3 times x is squared. So then how would you express this idea? How would you express this idea? How would you express this idea? Here, this part is read as 3 times x is squared. Here, squared of x, squared of x is taken 3 times, or the square of x is multiplied by 3, one or the other. The squared of x is multiplied by 3, or 3 times x, this part is 3 times x right here, is squared. So the whole thing is squared. And the result is divided by 7. Result is divided by 7. So that's it. The result is divided by 7. So 3 squared is 9, x squared over 7. That's it. That's the second part, B. Let's go on to C. The product of x plus 4, product of x plus 4 and y is added to 18. Product of x plus y, product of x plus 4 and y. What does product mean? Product means multiplication. Product means multiplication. So we take the product of this quantity x plus 4 times y. That's the product of x plus 4, product of x plus 4 and y. That's this part. And it's added to 18. And this part is added to 18. Or 18 is added to it. Same thing. 18 is added to it, or it is added to 18. It's the same thing. You can leave it like this, or you can expand it. Doesn't really matter. You can leave it like this, or you can expand it. X times y is xy, and y times 4 is 4y. That's it. That was C. Let's move on then. Second problem. Problem number 2. In second problem, it says simplify the following algebraic expression. That's what we deal with. Evaluating algebraic expressions, adding and subtracting, multiplying, dividing, all of this thing, you will be familiar with how to manipulate a given algebraic expressions. That's what this is. And like I said, it's meant for those people who are shaky in algebra. There are quite a few people like that I come across who never had a sound foundation in algebra. I don't know why. I do not know why the kids in the US are turned off in school with algebra, which is a shame. A shame. So if you happen to be one of those people who did not have an opportunity of learning algebra properly, there you have it. Simplify the following expressions. A. This is the second problem. 3x squared minus 6 plus x plus 11 minus x squared plus 5x. Let's see what we can do here. So we have to add and subtract what are known as like terms. Like terms. For example, all the terms that involve x squared. Here I see first one, here I see another one. This is a positive 3, this is a negative 1. A positive 3 and a negative 1 is going to give us positive 2x squared. Now we go on to the next exponent. Exponent, which is this is the exponent of 2. Now we look for the first exponent. This is the first exponent here, x raised to 1, x raised to 1, and I see 1 here and I see 5 here. They're both the same size. Plus 1 and plus 5 it gives us plus 6x. Then move on to the last exponent. But I don't see any other exponents, do you? Right here, negative 6, a negative 6, and a positive 11. Positive 11 and negative 6. Positive 11 and negative 6 is positive 5. Why did I refer to this as an exponent? I do not see any x with it. Is there any x with it? This has the exponent of 1. That has the exponent of 2. So we go in the descending order of the exponent. 2, 1. What about this guy? It does have exponent. Here it is. It does have x with it. It's 5 times x raised to 0. X raised to 0. In theory, it is there, even though you do not see it. Why? Because any number raised to 0 equals 1. So this is some quantity, it is raised to 0. So technically it is 5 times 1. 5 times x raised to 0 is same as 5 times 1, which of course is same as 5. So we don't see any of this thing. What we just see is 5 right here. We just see 5. We don't see, where is it? Oh, right here. It's a negative 6. What it is it's not negative 6. What it is it's a negative 6 x raised to 0. This is not 11. What it is 11 x raised to 0, which gives you positive 5 x raised to 0. But as I explained to you, since x raised to 0 is 1, we don't write it, because there is no point in writing some number raised to 1 times 1 is just a number itself. And it's called constant. It doesn't change. Which one was this? This was only number 1. Let's go to B. Let's go to B. In B, they give you 3 times 5x minus 1 minus x and plus 4. Let's see what we can do. Let's see what we can do. 3 times 5x is 15x, and 3 times the negative 1 is negative 3, and a negative x and a positive 4. Again, we're going to do the same thing. We're going to add up the like terms. Let's take care of the x's first. Here I see positive 15, and here I see negative 1. A positive 15 and a negative 1 is going to give us positive 14. It's going to give us positive 14x. So that takes care of that part. And then we have to deal with the constant, which is very simple, very straightforward. Here we have a negative 3 and we have a positive 1. A positive 4 is going to give us positive 1. So 14x plus 1 is the answer. Let's go to C. Let's keep C. Let's keep C in variance. Let's go deal with D first. What does D say? D says 2x plus 5. 2x plus 5 times 3x minus 1. Oh, we just have to expand it. That's all. We have to expand the thing and find out what's going on here. Two x times 3x. 2x times 3x is going to give us 6x squared, and then 2x times negative 1. 2x times negative 1 is going to give us negative 2x, and then 5 times positive 5 times positive 3 is going to give us positive 15x, and then finally we get positive 5 times the negative 1. It's a negative 1, keep in mind. Positive 5 times negative 1 is going to give us negative 5. We simply have to add up these two terms and that's it. So we end up with 6x squared, a negative 2 and a positive 15 is going to give us positive 13x, and a 5, negative 5. That's it, we're done with that one. That's it. Let's do C. Before I do the C here, allow me to digress for a second. What does it mean to digress? Digress means to go off topic, to change the subject. Allow me to change the subject, allow me to digress for a second. And when did we learn the word digress itself? Number 3. Let's learn this word, abeyance. What does it mean to keep something in abeyance? We probably figured out from the context. To keep something in abeyance means to keep something aside. We'll deal with it later. Let's put it aside. We'll come to it later, which is what I did. I wanted to deal with C later on. I said, let's just keep it in abeyance. Day number 9. If you're interested in improving your vocabulary along with learning improving your math skill with me, and if you're interested in improving your vocabulary, which I see no reason why you wouldn't be, because if you're about to take any of these tests, TOEFL, SAT, GRE or GMAT, this vocabulary is a must. Just type in my name, Keshwani, and then vocabulary, day 9. Vocabulary, day 9, and you will learn the word abeyance. Type in day 3 and you will learn digress along with some other useful, good words to know to help you improve your vocabulary for the GRE. Anyway, that was it. So why did I keep C in abeyance? Here's the deal. Now I could actually just brush it off and just put down the thing on the blackboard like lots of other videos that you see on the YouTube where person just stands there and just solves problems after problems. For those of you who have been watching my videos for a while now, you know that that's not what we do here. I want you to learn the math, not just simply watch somebody solve the problems. There are three formulas that we must know. It doesn't matter whether you're taking the GRE or the GMAT or the SAT, whether you're taking GMAT, GRE or SAT, there are three formulas that appear on a regular basis on these exams. Let's go through one by one, all three of them. The first one is looks like this: a plus b whole square. It is read as a plus b whole square. Don't just say a plus b squared. A plus b squared, a plus b squared is this, a plus b squared. That's what that is. This is a plus b whole squared. Whole tells me that everything that I saw before, everything that I heard before has to be put together and then squared the entire quantity. A plus b whole squared. The whole of it that is squared. What is that equal to? A plus b whole squared is simply a plus b times a plus b. A plus b times a plus b. Expand it out, we get a squared, and then a times b is ab, and then b times a is again another ab. B times a is same as a times b, and then finally b times b, we get b squared. And when you simplify it, you get a squared plus 2ab plus b squared. It is getting too crowded. I'm going to erase most of this thing. I should have done it a long time ago. It's getting too crowded. So what this thing boils down to is a plus b whole squared equals a squared plus 2ab plus b squared. You must know this formula by heart. Otherwise there is no hope. Let me give you an example of a typical problem that appears in the exam. If I can make one up, I'm taking a chance right now because I'm going to make it impromptu. Let's see what happens. Sometimes these things work out and sometimes they don't. Let's see how it works out. For example, a typical problem that appears is that they will tell you that a plus b is 7. They will tell you that a squared plus b squared is 40. That's the information that is given to you. And then the question simply is, how much is a times b? That's the question. It appears on something like this, does appear on the exam. The only way you can answer this question is if you know this formula. There is no other way here. There is no other way. So you have to apply this formula. A plus b, we are told a plus b is 7. 7 squared, just follow it. 7 squared, a plus b squared equals a squared plus b squared. A squared plus b squared, we are told, is 40. Plus 2 times ab. This is 49. 49 minus 40 is 9. So 2 times ab is 9. Therefore a times b is 9 over 2. And since this worked out to be 9 over 2, which is a weird looking number, I don't think it's going to appear as a multiple choice question because it gives the game away sort of. I don't know why. But it could also appear as a quantitative comparison question. They may simply give you information like this. They may simply give you information like this in the middle of the two columns. This is what is given in the middle of the two columns, and column A and column B. Column A simply says a times b and column B says 5. And of course our job is to figure out whether these two quantities are equal or one is greater than the other. We just found that a times b is 9 over 2. 9 over 2 is 4.5, therefore 4.5 is less than 5. Answer in this case would be B. But you cannot answer this question unless you know the formula that we just went through. Let's go on to the second formula. You must know these things. You must know these formulas. Second one is a minus b whole squared. Again, a minus b whole squared, which is simply a times b, a minus b times a minus b, which is a squared minus ab minus ba, which is same as ab minus ab, and then minus b times minus b is going to be positive b squared, and it boils down to a squared minus 2ab plus b squared, which is a minus b whole squared. That's the second formula that you know that you must know by heart. You must know it. And of course, if you don't know it, or if you memorize it, and if you sort of forgot about it in the exam, there is no need to freeze, there is no need to freak out. It only takes a few seconds to derive it, as I just did. I showed you how to do it. It only takes a few seconds to do it out and figure out what that boils down to. So don't take chances, don't make a guess, just do it out. Expand it, put down a minus b times a minus b, and just do what we just did, and it's right there. Let's do the last one. Last one is this. A plus b. So the first one was a plus b times a plus b. The second one we did was a minus b times a minus b. And the third one that you have to know is a plus b times a minus b, or a minus b times a plus b. What is that equal to? Let's find out, shall we? Let's find out. A times a is a squared. A times negative b is negative ab. Positive b times a positive a is going to give you positive ab. And positive b times the negative b is going to give us negative b squared. And what we find is that this negative ab and a positive ab cancel each other out, and we end up with a squared minus b squared. Let's make a note here. A squared minus b squared equals a plus b times a minus b. And this formula is known as difference of two squares. It is called difference of two squares. Difference of two squares is what we need in C in order for us to be able to answer the question. Let's take a look at C. Let's take a look at C that I skipped before. In C, they tell us that x squared minus 16. On the top we have x squared minus 16. We have to be able to recognize that x squared minus 16 is same as x squared minus 4 squared. X squared minus 4 squared, there you go, that's your a and b. Your a in this case is x, and our b is 4, which is going to boil, x squared minus 4 is going to boil down to x plus 4, and x minus 4, voila, x minus 4. And this is called the difference of two squares, the formula. And on the bottom they have x over x minus 4. On the bottom they have x minus 4, so we have to put that on the bottom, x minus 4. Now this is a quantity, this is one quantity, x minus 4 is one quantity, x plus 4 is another quantity, and those two quantities are being multiplied on the top. This quantity, x plus 4, is a quantity which is being multiplied by x minus 4, but we see the same quantity on the bottom, x minus 4 and x minus 4, they're going to cancel each other out. And the answer simply is x plus 4. So x squared minus 16 divided by x minus 4 boils down to x plus 4. That's the answer. So that was C. That was the end of it. I will see you tomorrow, where we will continue doing these problems. Alright? Have fun with these things. I'll see you tomorrow, okay? Bye.